So most people building with AI are using the wrong technique and are wasting thousands of dollars. And in this video, I'm going to show you how to avoid that mistake. So if you're building with AI right now and you're trying to decide of using RAG or fine tuning, then this video is for you. By the end of this video, you'll know exactly what technique to use, and then I have a design framework on what technique you should choose for what scenario. So let's dive in. So just to give you guys some context, I have a PhD in computer science and I work for the university as an AI research engineer, and I make chatbots for a living. And the number one question that I get when trying to work with a client is whether I should be using RAG or fine tuning. And I'm going to be showing you the common mistakes that can happen that can end up wasting thousands of dollars. So let's start with defining what RAG is, which stands for Retrieval Augmented Generation. So RAG is basically giving the AI a library card to pull documents from a certain database. So in the most basic sense, this is what Retrieval Augmented Generation looks like. So you have this system in place where it's retrieving information from this vector database. This is the library card analogy. It uses its library card to pull information or the documents you have stored in the database. And then you give that information that's relevant to the user's prompt to the AI, which is a generator or a large language model, and it generates a response to answer the user's question. Okay, and just to give you guys a concrete example of how this whole system works in practice, say that you're working with a client who has a bunch of policy data. So what you would do is you would grab all that policy data, you would chunk it up and index it and put it into a vector database. You can use something like ChromaDB Cone, which is a cloud service that you can use for a vector database. Then you can have a Python script that retrieves information from that vector database. So you could have a question on what's the cancellation policy. So the user's question will go through this system that retrieves documents according to the cancellation policy, and you give the information, that context, to the large language model, and it's able to answer the user's question. The reason why you don't want to give the entire policy information to the large language model is that there's research that shows that if you stuff too much things into the context window of a large language model, it tends to degrade the performance and it starts to hallucinate. And hallucination is a huge problem in large language models, where if you were to ask the system a question, sometimes it generates responses that aren't true. So that's the basic naive implementation of how RAG works. And you can see how this is such a powerful technique, because you can just give information to the large language model that's relevant, and you don't need to go through a long process of training the model and tuning its hyperparameters. Okay, so fine tuning is actually changing the parameters within the AI model. So if we were to look at this example, the large language model goes through something called pre-training. So initially, a large language model goes through a pre-training process. So you have billions of data that you would give to a large language model, and then it tries to predict the next word by tuning its parameters. So it produces a base model. And that base model is really good at generating the next word according to what context it has before. So this base model, you can think of it as ChatGPT or Claude, where it's able to serve a large range of people, and it's able to answer questions to a large range of people. It's using everyday conversations that most people can understand. But in some cases, when you are dealing with a certain domain, maybe you have medical documents, maybe you have legal documents, maybe there's a way that mathematicians talk, then you want to specialize that large language model to talk in a way that is familiar to certain types of users in those domains. So say you have a bunch of medical documents, you would further fine-tune or change those parameters to produce a specialized model that can serve that group of people. So in this image, it labels this data set as small data, but when you're dealing with large language models, the data set size depends on what kind of large language model you're using. So if you're fine-tuning a very big model, like maybe ChatGPT, then you would need a lot of data to actually change those parameters for the model. So for a large language model that's very big, you can think of it as an old dog. So an old dog, it's behaving a certain way and it has never learned new tricks. So its mind is not able to adapt to new behaviors as quickly as a younger dog. Okay, so just to give you guys a very concrete example of fine tuning. So in this case, you would have a base model. So maybe something like ChatGPT. You have a base model that's pretty good at answering questions. It can answer questions according to a wide range of audience. But then you have a client that's asking you to create a chatbot that talks in the same language as that medical doctor that's giving medical advice. So in this case, the small data that you would supply it is probably a lot of medical data. So imagine with the base model, you would ask a question: I have a headache, I have these symptoms, what diagnosis can you give me? And then it might answer your question very naively. It might not give you a full specific description of what diagnosis you have. But for a medical fine-tuned assistant, they might use more terminologies on the diagnosis that you have. It might ask certain questions about what other symptoms that you're feeling. So it talks in a way that's representative of an actual medical. When you're using Retrieval Augmented Generation, you're supplying documents to the AI model, but you're probably going to use some sort of base model that can serve a wide range of people. Whereas if you're using fine-tuning, you're actually changing the internal parameters of how the AI talks. So the fine-tuning method actually sounds like it's a better idea. So why wouldn't you use that all the time? So the catch is, fine-tuning a large language model actually uses a lot of computational resources. So if you were to fine-tune the large language models like GPT or Llama, then for one, you would need a lot of data in order for you to actually change the parameters of the model. And two, it actually costs a lot of time for you to train the model. Three, it actually costs money in order for you to fine-tune those models. And once you have this fine-tuned model, the knowledge is actually locked in. You can't easily change the knowledge that's locked into the large language model. So if something changes within your documents, then you need to do the whole fine-tuning process again. Okay, so let's try to break down the specific costs of what it takes in order for you to deploy a RAG system. So for one, deploying something like Retrieval Augmented Generation is very quick. So if a client came to me and they said they want to build a chatbot and they have this data set of documents, it would probably take me a few hours to set something up in order for them to talk to those documents. Or if it's something like fine-tuning, then I would need to do some research on actually what kinds of problems that client is trying to solve. I need to decide on what large language model to choose. I can't just choose the best one because it costs a lot of money to fine-tune it. So there's a lot more risk involved into that process. So the specific cost for using a Retrieval Augmented Generation model is that if they have a large number of documents, then you can use something like Pinecone. And Pinecone is relatively cheap to use. If you were to use the starter plan, and then we're just looking at semantic search of around 30,000 documents, where each document is around 20 kilobytes on average. So in this case, this is around 600 megabytes of data. So if you have over 600 megabytes, then you would need to use the standard plan, which is $50 a month. Or you can host the data yourself by using ChromaDB, and ChromaDB is completely free to use, and you just need to do a little bit more optimizations on how you're handling the data. Okay, so looking at the prices for fine-tuning a GPT model, I did the calculations here using Claude. We have, if you were to fine-tune the GPT 4.1 model with the same number of tokens, 600 megabytes, you would spend around $3,750 for GPT 4.1, for the mini $750, for the nano $225, and for the O4 mini, this is it uses hourly pricing and not token-based training costs. So anyway, if you were to fine-tune a model, you can see that the prices of fine-tuning is actually a lot more than if you were to use something like RAG. And in this case, you would need to downgrade that model in order to use something that's more appropriate to what problem you're trying to solve. So if you need a model that's trying to solve a very complex task, then you need to eat the cost of using GPT 4.1. And you can't even fine-tune your models on the GPT 5.2, 5.2 Pro, or the 5 mini, because they don't give you access to fine-tune those models. But in some specialized cases, if the task is relatively simple, you don't need to fine-tune these very big models. You can use something that's freely available online. But you need to be an expert in the field to know the capabilities of what large language model to use for each task. and you need to go through the process of trying to pick what model is the best to use for that use case. And last but not least, if you use Retrieval Augmented Generation and you have new documents that your client is giving you, you're able to just quickly update the database to ingest that new documents, and it has access to new documents whenever it needs it. Whereas fine-tuning, you need to go through the process of finding what model to use and actually going through the fine-tuning process, which is costing you and the client money. So here is a list of use cases of when you should use Retrieval Augmented Generation. So if your information changes very frequently, so imagine you have company policies that update monthly, maybe you have new product catalogs. If you're building a chatbot that looks at news and the current event, then you would need to use something like RAG because it needs to dynamically update its database in order to have access to those new information. And if you need to cite sources, so RAG, since it's retrieving those documents from the database, you can actually show it to the user and say, hey, I got this information from these sources. And then as the user, they can go ahead and click on those documents and validate whether that answer that the language model is saying is true or not. And that also goes with transparency. So when the AI is showing the user the specific sources of where it got its information from, then it improves the transparency and the trust of the user. And if you're building a prototype or an MVP, it's really quick to set up a Retrieval Augmented Generation system, and then you can have something working in a matter of a week or two. So what are cases of when you should use fine-tuning? So for one, if a client comes to you and they say that they want the language model to behave a certain way, maybe they're in the legal field, maybe they're in the mathematics department, they want the AI to talk in a way that's familiar to them. So if you're doing some sort of automation task, maybe that medical client that you have wants to draft a certain report, and that report is based on historical records of what the reports look like in the past, and they can't afford for the large language model to drift away from generating the report of how clients want it. So the key here is using Retrieval Augmented Generation. You can tell the model to behave a certain way. You can use prompt engineering techniques, but the key here is that if you're using fine-tuning, it's much more consistent in the way that it is generating information to the user. And for two, if you are pushing the boundaries of research and you are experimenting with reasoning models, so in this case, research has shown that if you were to tell the model to do some thinking before it generates an answer, it tends to improve the performance. But in that case, you need to fine-tune the model in order for it to do thinking on its own. And three, if the response time is critical. So in my cases, using something like Retrieval Augmented Generation, depending on how many documents you have in your database, the retrieval method can actually take a lot of time. So if you're using fine-tuning, you're changing the internal parameters of how the language model generates answers. So when you ask it a question, you can produce the answer right away. But if you were to use Retrieval Augmented Generation, then it needs to take the user's question, compare it against the vector database, pull the relevant documents, and then the model needs to ingest even more context in order to produce that answer. So I hope that clears up some misconceptions of when you should be using RAG or when you should be using fine-tuning. So here's a quick, simple decision framework of when you should use RAG versus using fine-tuning. So if your data is changing very often, then you should use RAG. If you need to cite sources or show where the information came from, you use RAG. If the specific tone or style needs to be in a very consistent format, then you would use fine-tuning. If you're building a sort of prototype or if you're testing an idea, you would use RAG because it's faster to iterate on. If you have a lot of high quality data, then you could consider using fine-tuning. But if you don't, then you would need to use internal domain knowledge of the domain that you're trying to build it in. Then you would use fine-tuning. But you could probably use RAG, but it would need some extra finessing in order for the AI to know how to answer the user's question. Okay, so let's wrap this up. I hope you guys got what you need from this video, and I hope the problem that you're having, you can decide of whether you need to use RAG or if you need to use fine-tuning. If this video helped you in any way, please consider subscribing to my channel and hit that notification button to get new updates when I post a new video, and I'll see you guys in the next one.